Hello and welcome to my YouTube channel. In this video, I am going to explain how to draw shear force and bending moment diagram of a cantilever beam. Cantilever beam which has one point load acting downwards. Cantilever beam is a beam which one end is fixed and the other end is free. As you can see, we have only one support at point A. At point B, we have no support, but we have a load which is acting downwards. The example of cantilever beam you can see in real life. We have staircase, for example, which are outside of our building. One side is fixed in the wall and the other side is not fixed, it's free end. So this is the example of cantilever beam. So same as we have three steps: reactions, shear force diagram, and then we have bending moment diagram. Okay, the reactions are very simple. We have only one support reaction, so all the force, all the load which are acting downwards, only one support will react it, will support it. So reaction will be RA is equal to 5 kilonewton, because 5 kilonewton is downward, acting downward, and our point A is supporting upward our beam, so it is also 5 kilonewton. So it will be 5 kilonewton. Okay. So on base of that reaction, we have to draw a shear force diagram. So how it would be: 5 kilonewton going upward, so something will be like that. So this is 5 kilonewton. To get to point B, we have to draw a straight line and then 5 kilonewton down. This 5 kilonewton is coming downward. So this is our all positive zone. So this is how our shear force diagram will look like for the cantilever beam. Okay, now we have to draw a bending moment diagram. In these type of beams, we can draw bending moment from right to left or from left to right, and then right to left. So in here I am going to draw from left to right. On this line, final line, I will draw from right to left. Okay, so now we have to calculate bending moment. So bending moment at A will be 0, as we know from our previous video. So it will be 5 multiplied by 0 is equal to 0. We have no arm, so the force rotates around this support, it will be 0. Now bending moment at point B will be 5 multiplied by the distances. Sorry, I forgot to write the distance. The beam is 2 meter length. Okay, so it will be 5 multiplied by 2 is equal to 10. Okay, now at point B we have nothing, we don't have to write anything, we already draw point B. So we have 0 and 10, only two values. So when we draw bending moment diagram from left to right, it will be something like that. Okay, so at point A we have 0, at point B we have 10. So this is 10. In bending moment diagram, we draw diagonal lines. Okay, so it will be something like that. So this is our bending moment diagram in positive zone. Okay, positive zone. Now as you can see, our load is acting downwards. We can draw bending moment in negative zone as well. So how do we do that? So I need to calculate it as well. Start from point B, not from A. This is from point A, now from here, point B. Bending moment at B. As you can see, 5 kilonewton is acting downwards, so it will be minus 5 multiplied by 2, it will be 0, point B, so end points are 0. Bending moment at A, minus 5 multiplied by 2 is equal to minus 10 kilonewton. Okay, now at point B is 0, so here is 0 kilonewton. At point A we have minus 10, so it will be minus 10. So you go down and then connect the points. So this is a diagram in negative zone. That's how we draw shear force and bending moment diagram for cantilever beam with 1 point load acting downwards. That's it for today. Thank you for watching my video. Please don't forget to subscribe my channel.